Hello, in today's video we're going to be talking about covalent bonds. So what we talked about in last class is we talked about those ionic bonds that can form and how to name those compounds. Just to recap, for the ionic bonds, we know that one of the elements is going to be giving up 1 or 2 or 3 electrons, and the other element is going to be gaining a certain number of electrons. The element that gives up the electrons is known as the cation, and it will be the metal that's found on the periodic table, so on the left-hand side of the periodic table. The nonmetal will be the anion. It is going to be the element that gains the electron. And the way that these elements, these ions, form a compound is through electrostatic interaction. We have a positive, we have a negative, and when they come together or get close enough to each other, they can actually feel that negative and positives, opposites attract. So that's how these compounds stay together. Covalent bonds are a different type of bonding. So unlike where one element gives up an electron and one element gains an electron, in a covalent bond what will happen is both elements will share all of the electrons. So let's take a look at a simple example. Let's take a look at hydrogen. So we know that hydrogen has a single proton and a single electron. So I'm going to draw hydrogen looking like this. We know that in reality we have to shade in around that sphere for where that electron is, but to make it easier for me to draw, I'm going to draw the electron circling around on the outside of this orbit. So this is going to be the first hydrogen. We're going to have a second hydrogen that has only one proton and only one electron, so we draw the same type of surface here. Now this is what the hydrogen atoms look like when they're apart from each other in their natural states, just flying around in space. Now, as these things get closer together, this could happen through either increase in temperature, where the atoms are starting to move more quickly and they're seeing each other more often. It can also happen if we decrease the volume of space that these atoms are present in. So if we decrease the volume, that forces these atoms to be closer together. So if this happens, what will end up happening is we're going to get a stretching of where the electrons are. And the reason for that is we have a positive in the center of this atom, and we have a negative on the outside of this atom. So as these things come closer together, this negative starts seeing that positive and wants to be drawn towards it. Same thing happens with this negative. This negative sees this positive and starts to be drawn towards it. So we get a shape difference as these elements come closer together. So what we end up getting is something, I'm a horrible drawer, so bear with me, something that's a little more oblong. We have the protons over here, but now the electrons are being drawn to the other proton. So this electron is being drawn to this proton, this electron is being drawn to this proton, and actually deforms the shape of the electron density. As these things get closer and closer and closer together, eventually what happens is we get an overlap of the two. So this is far apart, this is coming closer together, and then once they're really close together, we get the two positives, the two protons, at a certain distance apart, because we know that the same charges repel each other, so they won't overlap, but they will come close together, and then we'll get an overlapping of the electrons. The electrons will tend to stay in between the protons, and that's because this electron is now seeing multiple positive charges. It is happier that way. This negative is seeing multiple positive charges. It is happy that way. So what we end up getting is I'm going to shade in the electron density. In between the positive charges, I get a very dense electron cloud. So the electrons are spending a lot of time in between those two positives. As we go on the outside, it gets less and less. It gets less and less. So as you can see, we now have a different type of a structure, and this actually forms a bond. This would be called just hydrogen, but it's H2. This is a covalent bond. So this is how a covalent bond differs from an ionic bond. In ionic bond, there's this give and take of electrons and then the electrostatic interaction. In a covalent bond, all of the electrons are being shared. So this electron will sometimes spend time around this proton. This electron will sometimes spend time around this proton. They're just following around. flowing around the positive charges. So that's the difference. In class tomorrow, we'll learn how to name these compounds. They have a very simple name. And so by the end of tomorrow, you'll know how to name almost everything that we're going to have to name for this class. With that, I want to say I will see you all in class tomorrow.